Great. Welcome to another Real Publishers book discussion. This time I have with me Professor Ramjee Prasad, founder president of CTIF Global Capsule at Aarhus University and founder chairman of Global ICT Standardization Forum for India. And I also have Paulo Sergio Rufino Henrique, integration engineer at Studio, and also a PhD student at Global CTIF Capsule at Aarhus University, looking at 6G networks. And we are all here today to talk about their book, 6G, The Road to Future Wireless Technologies 2030, which looks ahead at the development of 6G networks. So welcome both of you and thank you for joining me today.
Thank you.
Thank you. Thank you. Thank you, Philippa.
I guess the first question would be, what exactly is 6G? What can we expect from the next generation?
Okay, so 6G is the future wireless technology, the next generation of cellular networks that will overtake in the 5G networks. In a nutshell, it's a huge architecture, a huge development we are doing across all the scientific community to study and prepare for the next 10 years this novel network. But in summary, 6G will bring many innovations and also will enable a synergy between the cyber space and the physical realm. So we're going to be able to have technologies that will be served by 6G networks to bring both worlds together and deliver new use cases that are not able to be used yet in the new 5G infrastructure. And also we are going to have in this technology, for instance, the minimum information at least to share here is that we'll be at very fast working terabits speed, terabits per second, utilizing the new radio frequency spectrum in terahertz, and will, as I said, bring a lot of innovation, which will create this novel architecture.
Okay, and you kind of brushed upon this, but what are some of the key technologies or use cases we could possibly expect from 6G?
Okay, so some of the use cases and technologies, for instance, we can expect on this novel network that will be released in 2030 are, for instance, the total use of artificial intelligence and probably mixed with machine learning, because this technology, this new cellular network, this new wireless networks needs to be totally intelligent. In order to bring this intelligence, we need to be fast, and this technology needs to be cognitive, understand everything that is happening at the edge of the network and also in the core of the network. And to achieve this, probably we're going to have what we call quantum machine learning, which will be bringing quantum computing. And in terms of use cases as well, I want to highlight some of them, but also share here with my professor, my supervisor here, my PhD, Professor Prasad, because some of the use cases are to use holographic communications. Okay. For the first time, we're going to have holographic type of communications. People can communicate in 3D, and also we can share real virtual reality world in real time. But also two use cases that are very important. It's part of the core of the studies of Professor Prasad, which is CONASENSE and knowledge home. I will ask Professor Prasad to explain more about it, which is very interesting. Professor.
Paulo, I think Philippa, Paulo has told you what 6G is, a bit about technology also he has mentioned. As you are all aware that every 10 years we have the new generation of the mobile communication. 1980 we had the first generation, then 2000 we had the second generation. 2000 if I'm correct. 1990. 1980 first generation, 1990 second generation, 2000 third generation, 2010 fourth generation, and 2020 we have the fifth generation, which is getting implemented throughout the world. In Denmark, it is being implemented all over the country already. And now we are looking forward for the future generation. That is what we call 6G. And that will happen in 2030. And that is a topic which we have covered in our book on 6G. As Paulo mentioned, we have covering for many technologies. Two important technology which I want to just tell you briefly is about knowledge home. Home stands for human-bound communication beyond 2050. So H has been taken from human, O has been taken from bond, M has been taken from communication, E has been taken from beyond. So home stands for human-bound communication beyond 2050. Now remember, generally, if there's a home, you and I say this home belongs to me. But this home belongs to every citizen of the globe. Here, we create the knowledge, and knowledge is getting transferred globally to use the advantage of that. So knowledge home is a platform where we can create the knowledge for the future technology and utilize it. And for 6G, knowledge home will be very much utilized. Although I call knowledge home human-bound communication beyond 2050, but this will play very important role in 6G, 7G, and beyond. That's what I want to critically mention it. Then coming to the CONASENSE, it is nothing but integration of communication, navigation, sensing, and services. So CONASENSE, communication, so CO is communication, navigation, NA is taken from navigation, CONASENSE, communication, navigation, and services. Then we took AC from services that make the CONASENSE terminology. This is very important terminology for the future development of new generations, because naturally it will be a hybrid model combining communication, navigation, sensing, and services. We have very well explained in the book of 6G about CONASENSE and about knowledge home. Just for your information, CONASENSE, we have a book, and same thing, we have the book also, knowledge home. One can refer those books.
Okay, so CONASENSE, with regards to 6G, is going to be using the potential 6G networks to combine, like you're saying, communication, sensing, and all those inputs. I guess kind of my final question then would be, you say to expect 6G networks in the next 10 years or so, which doesn't seem that long to me, but what are the challenges we are facing to bring 6G networks in that amount of time?
Paulo, please go ahead.
Yes, thank you, Professor. One of the challenges are, first of all, to understand and create a robust architecture that could be intelligent, green, in order to save energy, especially in the current situation we are living in, and to be a key enabler of the societal development goals that United Nations has mapped, and which is focused to be achieved, most of these goals, with the efforts of technology as well, which includes reducing poverty, decreasing the digital gap, as we are seeing now during this pandemic situation. So how is important for us to be connected, and how the mobile economy is enabling the world to continue progressing. So everything that we do nowadays is currently digitalized, and we depend on wireless networks. And in order to continue delivering this and enabling the new evolutions, the new innovation that will bring more development for our society, we have to have these technologies. And one of the key challenges we have here as well is to enable quantum computing, because quantum computing is being studied to be utilized inside of the 6G networks. And we discuss this. We have a special topic inside of this book discussing about this technology. And in terms of the use cases, we are going to see, for instance, we're going to see 6G being deployed in space travels. We are now seeing NASA in the US building 4G networks in the moon, and 6G will follow this because telecommunications will enable us to continue the space explorations, also underwater communications, and so many other applications that we are envisioning as a future opportunity to utilize 6G as infrastructure, as a road to be deployed, including optical wireless communications in online offsites. These are type of examples in which we are exploring further in this book, and we invited all of you to take a part and understand.
Well, thank you both for joining me today. I'm afraid we have to end it there. But yes, thank you. It's been very interesting, very exciting to hear about some of the use cases potentially for 6G. And yeah, thank you very much.
Welcome.
Thank you. You're welcome.